Example 4. Please calculate the delta H of reaction 1. There is a standard solution for this kind of problems. However, the standard solution generally is very time-consuming, and it is a little difficult for the student to master. Over the years of teaching, I have invented a new method. It is more effective, and it is less time-consuming. Now let me show you the new method. I prepared a flowchart for the new method. The first step of the new method is to get a fraction from each chemical equation. Let me explain how to get a fraction from each chemical equation. In a chemical equation, if a chemical is a product, it will be in the numerator of our fraction. If a chemical is a reactant, it will be in the denominator of our fraction. The coefficients will be the power terms in our fraction. For example, C2H2 is a product. The coefficient is 1. Therefore, we will put C2H2 in the numerator. The power term will be 1. For carbon, the coefficient is 2. Carbon is a reactant. Therefore, in our fraction, carbon will be in the denominator. The power term will be 2. Similarly, we can write down a fraction for each chemical equation. Now let's look at the flowchart. The next step is to set up a math equation with unknowns. The unknowns can be x, y, z, etc. It can also be alpha, beta, gamma, etc. The number of the unknowns should be equal to the number of chemical equations whose delta H reaction is known. Let me emphasize, the number of unknowns is equal to the number of chemical equations with known delta H reaction. For this problem, we have 3 chemical equations whose delta H reaction is known. Therefore, we should have 3 unknowns. Now let me show you how to set up the math equation. We have 3 unknowns. We can call them x, y, and z. We can also call them alpha, beta, and gamma. Let's use x, y, and z. For the first equation with known values of delta H, let's assign x to it. We multiply x for every power term. For the second equation with known values of delta H, we will assign y to it. Therefore, we will multiply y for each power term. For the last one, we will call the unknown z. To set up the equation, the delta H of the equation we are looking for will be on one side. Because we are looking for the delta H of this chemical equation, therefore, its fraction should be on one side of the math equation. Then, everything else will be on the other side. We will multiply each other. Now let's look at the flowchart. The next step is to calculate the values of the unknowns. Well, when you first look at this equation, it is a little intimidating. However, it's very easy to solve this equation to find the values of x, y, and z. Now let me show you how to do that. Well, what we need to do is we try to get rid of the denominators. We will change it to this format. If it is a denominator, we will add a negative to the power term. Therefore, carbon to the second power will become carbon to the negative 2 power. Hydrogen to the first power will become hydrogen to the negative 1 power. We will do the same for every term on the right side as well. Then we will combine the same chemicals together. For example, for CO2, we have 1 term, 2 terms. We will combine them into 1 term. It will become CO2 4x plus y power. We will do the same for all the other chemicals. Now we can try to calculate the values of x, y, and z. What we are going to do is, we will start from the left. You see, the power term for C2H2 is 1 on the left side. The power term for C2H2 on the right side is negative 2x. The power term on the left must be equal to the power term on the right. Therefore, we will get 1 is equal to negative 2x. X is equal to negative half. Then for carbon, on the left side, the power term is negative 2. On the right side, the power term is negative y. Therefore, negative 2 should be equal to negative y. Therefore, y is equal to plus 2. Let's continue for hydrogen. The power term of hydrogen on the left side is negative 1. On the right side is negative 2z. Therefore, negative 1 should be equal to negative 2z. Z is equal to plus half. Now let's look at our flowchart again. The last step will be calculate delta H reaction. Delta H reaction is equal to delta H1 multiplies X plus delta H2 multiplies Y plus delta H3 multiplies Z until you finish for all unknowns. Because for this particular problem, we only have 3 unknowns. Therefore, we only add up 3 terms together. Now let me show you the work. Delta H1 should be this one because we assign X for this equation. X is equal to negative half. We multiply negative half. Delta H2 should be the delta H here, which is negative 393.5. Multiply Y, which is equal to positive 2. Then we add the third delta H, which is negative 571.6. Multiply Z, which is positive half. After you plug all the numbers into a calculator, you will get 226.8. We're done. Can you answer these 2 problems by yourself?